Okay, we're continuing with our econometrics final review. For question 22, you're given raw data on income and age. You have four observations. The dependent variable is income and the independent variable is age. And you're asked what the coefficient on x is, so the value of the slope. Now, in order to calculate this, we need to use the formula for the slope, which is equal to the sum of x minus x bar times y minus y bar divided by the sum of x minus x bar squared. So the first thing we need to do is we need to calculate the mean value of y and the mean value of x. And so we obtain these values as such by just taking the average of these four observations, divide by 4, and the average of these four observations, divide by 4. And then we take a column. We create a column y minus y bar and a column x minus x bar, where we're simply taking deviations from the mean. So for the first observation, it's 40 minus 41.25. For the second one, it's 30 minus 41.25, and so on. Now, as a check, we can take the sum of this column, and it should always be 0 or approximately 0. If it's not exactly 0, it's likely due to rounding, but it should be very close to 0. We do the same thing with x minus x bar, 32 minus 31.5, and so on, and the sum of that as a check should be equal to 0. We then multiply these two columns in order to obtain a column for y minus y bar times x minus x bar, and so we do this for every observation. Then we take the sum, and this sum over here is the value that goes in the numerator for this formula for the slope. And then for the denominator, we take x minus x bar squared, so each of these values is squared. A negative 6.5 times a negative 6.5 is 42.25, so none of the values in this column should be negative, and the sum is 281, and that goes in the denominator. So for the slope, 582.5 divided by 281 is going to be 2.0729 or 2.0730. The value of the y-intercept, again, we're going to use the formula. This time we're using the formula for the y-intercept. We always calculate the slope before we calculate the y-intercept, since you take the value of the slope and place it into the formula for the y-intercept. So the y-intercept is simply y bar, which we already calculated, is 41.25, minus the value of the slope times x bar, which is 31.5, and we obtain a value of negative 24.0495, or without any rounding at all, negative 24.0480427. They're very similar in value. Now you're asked, is the slope positive or negative? So we find that the slope is positive, and you want to interpret the meanings of the parameters. So the slope is clearly positive as age goes up by 1 year, predicted income goes up by 2.073 units, and then for the y-intercept, when age is equal to 0 units, predicted income is negative 4.05 units. Now that doesn't make economic sense since it's a negative number, but we will still interpret it. Often we are not interested in the range that the y-intercept is in. Now for question 23, we have an N of 20. We have 20 different towns, and we're predicting body mass index using the following equation. So you have what we call an analysis of variance, or ANOVA model, where you simply have a dummy variable as the independent variable, and BMI as the dependent variable. So you're interpreting the meanings of the parameters. And you can interpret this in multiple ways. So you can say, well, for mean BMI or average BMI or predicted BMI or expected BMI is equal to 24 for females. So if we plug in a value of 0 for males, right, then we're looking at a group of females. So it's simply average BMI is 24 for females. That's for the y-intercept. For the slope, we can say, on average, males have a BMI that is 2 units higher than females. Or we can say predicted BMI is equal to 26 for males. And that's why we often call this value over here a differential intercept coefficient, because all it really does is change the intercept. Okay. Now we're given the standard error for the male coefficient, which is 0.05. So we're asked, can we say that the male coefficient is statistically significant at the 5% level? So we're looking at whether it's significantly different from 0. So the null hypothesis is that beta 1 is equal to 0. The alternative is that it's not equal to 0. We're looking at a two-tailed test with an alpha level of 5%. Degrees of freedom are equal to 20 minus 1 minus 1, or 18. So degrees of freedom are equal to 18. We're looking at a two-tailed test with an alpha level of 5%. So we're looking, right, two-sided, 5%. We go down, we see that the critical t-value is 2.10. So the critical t-value is 2.10. We know that the actual t-value is the value of the coefficient divided by the value of the standard error. So 2 divided by 0.05 is 40. This is clearly much greater than the critical t-value of 2.10. So we can easily reject the null hypothesis and say that there is a relationship, or that the male coefficient is significant at the 5% level.